The second type of halogenation substitution reaction that we're going to be dealing with involves an alcohol. And you're going to see that the reaction conditions here become a bit tricky, but I'm going to try my best to explain to you as best as I possibly can. So, in these reactions, we are going to have an alcohol reacting with anhydrous hydrogen halides. So a reminder, a hydrogen halide is just a hydrogen atom bonded to some halogen, which could be chlorine, bromine, or iodine, for example. The word anhydrous simply means that we may not have water present in our hydrogen halide. So there's no water here. This reaction takes place without the presence of water. And in the end, we are going to form haloalkane. So the product of these reactions are haloalkanes, and you'll see we'll have a byproduct of water as well. They say here this reaction is the reverse of the hydrolysis of haloalkanes to form alcohols. So the reaction conditions. These reaction conditions can be a bit confusing, because you need to be able to distinguish between tertiary alcohols and primary and secondary alcohols. So as we go along, I'll remind you of the difference between them. But the important thing here is to understand that tertiary alcohols don't need the presence of heat. They will react with a hydrogen halide at room temperature. On the other hand, primary and secondary alcohols, you will see in the process there's a reaction that takes place first to form the hydrogen halide. After that, however, you're going to take your alcohol and you are going to react it with that hydrogen halide, but it must be heated. So the reaction condition when you have a primary or secondary alcohol is the presence of heat. And you now know that we show that with a triangle. In these reactions, you're going to see we start off with an alcohol and a hydrogen halide. They will react in the presence of heat, or if it's a tertiary alcohol, then there will not be heat, and they will form haloalkanes and water as a byproduct. So let's start off with an example of a tertiary alcohol. A tertiary alcohol is one where the carbon onto which the OH is attached, that carbon is bonded to 3 carbons. It itself, that carbon is bonded to 3 other carbons. And then we call this a tertiary alcohol. So here we have 2-methyl-propan 2-ol. This is the alcohol that we are going to react. We're going to react it with hydrogen bromide, which is a hydrogen halide, okay? So hydrogen bromide. And this is how the reaction is going to take place. So at this point where we have our OH or hydroxyl group, the hydroxyl group is going to detach. It will then switch places with the halogen atom, in this case bromine, so that instead you will have bromine attached here, and instead of bromine here we will have an OH. And therefore the product of this reaction is 2-bromo-2-methylpropane, where instead of the alcohol's OH, the alcohol's functional group, which is a hydroxyl group, instead of that we now have bromine. So we now have a haloalkane forming and water. So notice that this takes place at room temperature. They've indicated it here, but you don't need to write down room temperature when I ask you to write down these reactions. Now we move on to the primary alcohols and secondary alcohols. A primary alcohol is one where the carbon onto which our hydroxyl group is attached is only bonded to one other carbon. So remember, carbon has space for 4 bonds. The one bond is to the OH, the other bond is to the carbon, and the other are taken up by hydrogen. So this is primary because our carbon is only bonded to one carbon. The carbon to which the hydroxyl group specifically is attached is bonded to only one other carbon. When we have a reaction involving a primary alcohol, Then we need heat to be present, so we could have instead just drawn this triangle. The reaction is similar to the one above. Our hydroxyl group will detach and it will change places with the bromine, chlorine, fluorine, whichever hydrogen halide you are reacting with your alcohol, it will switch places with the halogen. So instead of having this hydroxyl group there, we will now have bromine, and instead of bromine here, we will have an OH. So in the end, we form one chloropropane, not propan, propane, okay, because we have this bromine atom on the first carbon, and water as our product. The last example I'm going to show you is one involving a secondary alcohol. So secondary alcohols are those where the carbon atom that our hydroxyl group, our functional group for alcohols, is attached to, that carbon is attached to two other carbons. Okay, so when it's primary, the carbon is attached to one other carbon. When it's tertiary, it's attached to three other carbons. And when it's secondary, it's attached to two other carbons. So we will then react this alcohol, which is propan2-ol, with a hydrogen halide. In this case, we are using hydrogen chloride. Then what will happen is our OH will break, so the bond between the carbon and the hydroxyl group will break, and our OH will be substituted, so it will change places with the alkane, sorry, not alkane, the halogen, in our hydrogen halide. So it's going to switch places with chlorine, so that we will have chlorine here, and we will have our OH attached there. We then have an alkane forming, specifically here we have 2-chloropropane and water as a byproduct. This is halogenation involving alcohols. Remember, we do have addition reactions that are halogenation as well, but we know that this is a substitution reaction because we started off with something that was saturated. It reacted and formed a saturated product. Saturated means we are dealing with a substitution reaction. It's that triple S, right? Saturated to saturated is a substitution reaction.